right. Implicit differentiation. Okay. So everybody understand what does implicit mean? No. Do you understand explicit? No. Explicit. So I would say the reverse. No, it's not a reverse action. It's another word for compare with implicit is called explicit. Explicit. Okay. It's called explicit. Okay. Function. Okay. What kind of function is called explicit function? Okay. So example. Okay. So example. Y equals f of x equals. So example. X squared minus 2x plus whatever 2. So example. I just pick up a function whatever. Okay. We call this function is called an explicit function because what? We may describe y explicitly in terms of what? X. See? We can separate the function of x on one side and this variable y on one side. So this function we call it is what? Explicit function. We may separate x and y. Okay? So it's called explicit function. To find the derivative of an explicit function, how? Remember we learned all of these rules, right? Okay, power rules, product rules, quotient rules, chain rules, many rules, right? So what is the derivative for this function y equals x squared minus 2x plus 2? It's easy, right? So the derivative should be what? 2x minus 2, done. Okay? Or if we have some other, functions, say trig function or some other functions, exponential function, something like that. If we could write y, separate y, or isolate y on one side, and everything else in terms of x on the other side, we call this type of function is explicit function. Okay? Well, sometimes we may not be able to write y in terms of x explicitly. See the example. Okay. This line, 2x squared plus xy minus y squared equals 2. We say y is a function of x, means y is a dependent variable, x is independent variable. Now question for you, can we isolate y on one side and then everything else is function of x on the other side? Can we separate y from this equation? Can we? No. But y is still a function of what? X. So this kind of equation gave us what? An implicit function of y with respect to x. Do you see the difference between explicit and implicit? Implicit means what? They're staying together. We're not able to separate y. Okay, we're not able to separate y alone. Okay, so it's called an implicit differentiation. But still here, y is what? Y is a function of x. Okay, so if we encounter this type of situation, okay, how can we find the derivative of y with respect to x? How can we differentiate y with respect to x if we're not able to separate y alone? So this is the idea that we have to learn. Okay, this is the idea about how to compute the derivative of y. We still compute the derivative of y with respect of x without what? Solve for y. Okay, without solving for y, without isolating y, we'll still be able to compute what? Derivative of y with respect to x. Okay, so that's the method, okay, the method of implicit differentiation. I'm going to ask a volunteer to read it. Didn't?
I can read it.
Simon?
The method of implicit differentiation, this consisting of differentiating both sides of the equation with respect to x, and then solve the resulting equation for y prime.
Okay, very good. This is a typo. Yes, you're right, both. Okay, so how to solve for dy over dx? Well, y prime, okay? So dy over dx, this is y prime. How to differentiate y? What we do is, we're not able to isolate y, but we're going to what? Differentiate both sides of the equation. Okay, from both sides of the equation, differentiate with respect to what? X. Okay, then solve for y prime, okay? So now let's use this question as an example, how to do implicit differentiation. You have to know how to do it, okay? Absolutely, I'll give you a test question about to let you compute implicit differentiation, okay? So what you do is, I don't like this pen, okay, let me change to a different one, which is so far my favorite pen is, where is Clemens? No, I need a little more, okay? I remember okay, I'm gonna use this one, okay? That's my favorite, but I think I forget it in the office, okay? So differentiate, okay, this equation from both sides, okay? Differentiate both sides with respect to what? X, okay? Differentiate this equation from both sides with respect to x. So left hand side, we're going to have d of this entire thing, 2x squared plus xy minus y squared dx, okay? Right side, it is d of constant 2 dx. Okay. Now let's see. 2x squared differentiated with respect to x. What should we have for x? Okay. Now I'm going to differentiate x times y with respect to x. Keep in mind that y is a function of x. Okay. So how can we differentiate x times y? Is this a product? Yes, it is, right? So by using product rule, we're going to differentiate x with respect to x, give us what? 1 times by y. Plus what? Plus what? X times by what? dy over dx. Okay, so these two comes from what? The differentiation of x times y. Okay, x is an independent variable, y is a function of x. So when we differentiate y with respect to x, we write dy over dx, and this is our y prime, right? You see that? Product rule, right? Differentiate x give us 1 times y. Differentiate y give us dy over dx times by x, right? Everybody? Okay, now differentiate negative y squared. Which rule should we use? The chain rule, right? Y is a function of x, okay? But this is negative y squared. How to differentiate negative y squared? By using the power rule first, right? And combine with chain rule. So negative y squared negative 2y times by what? dy over dx. Okay? So differentiate negative y squared with respect to x. Okay, first we have to do with a negative y squared. The derivative gives us negative 2y, right? And then by chain rule, times by what? dy over dx.
Why couldn't you choose the power rule?
We're using power rule.
Well, why didn't you dy over dx?
Because it's not different
Because-
with respect to y.
Because this is differentiated with respect to x. If we are differentiating negative y squared with respect to y, we're done here, negative 2y. However, y is a function of x. So that's why we have to multiply by what? dy over dx. This is the most tricky part. See, that's why I'm using the red pen to emphasize that. Okay?
I actually can't see a color difference. Can anyone else?
No, you cannot see? Okay, from here you can see, but from that you can only see black, right? So it's not your problem. It's I think the projector's problem, okay? So the red one, okay, yeah, it doesn't matter, okay? You can tell from this arrow, right? Can you tell from the arrow? Okay, so this comes from the differentiation of negative y squared with respect to x. Okay, how about the right side? What is a constant derivative with respect to x? 0. Okay, so this is the most important step for implicit differentiation. Differentiate both sides with respect to x. Keep in mind, y is a function of x. Okay. All right. Now we know that dy over dx is what? Y prime, right? Y prime. Okay, so how to solve for y prime? Because we need to find the dy over dx, right? Well, y prime. Okay, once we differentiate both sides with respect to x, then we need to solve for dy over dx, or y prime, right? Solve for y prime. How? You see how many terms do we have? We have 4x term, right? We have a 4x, we have a y term. We have x times dy over dx. We have a negative 2y times what? Dy over dx. So I would say this term and this term, both of them, they are having what? Dy over dx, right? So they are considered to be what? Like terms. Can we combine them? Yes. So we'll have x minus 2y times by dy over dx. Can we? Okay. And then...
But aren't you subtracting the second like term?
What do you mean second like terms? Yeah, we are.
There's a minus.
This is x times, this is negative 2y times, right? So once we pull the dy over dx, we'll have x, we'll have a negative 2y.
Okay, that makes sense.
And then this 4x and y, we don't want them because eventually we want to isolate the dy over dx, right? So how do we deal with them? Subtract them from both sides. Subtract 4x, subtract y from both sides. Okay, so this gives us what? Negative 4x minus y. You agree with this, right? Then we want to isolate dy over dx. How? Divide by x minus 2y from both sides. So, that. There are only two steps. One step is differentiate both sides with respect to x. The second step is what? Solve for y prime. Or solve for dy over dx. Excuse me. However, the differentiate both sides with respect to x, that's a challenging step. Okay, challenging step. Alright, now we have the question B and C. Okay, I want you to try both of these questions by yourself. Give it a try, and then I'll show you the answers. Okay, so the idea is the same. Okay, the idea is the same, but you want to encounter different kind of the questions. See this one, cosine of x times y equals 1 plus sin of y. There's no way we can isolate y on one side, so we have to use implicit differentiation. Okay, this one, same thing. E to the x over y equals x minus y. See, y is here, y is there, so there's no way we can separate y, right? So we have to use implicit differentiation, okay? But when we do the differentiation, make sure that we are going to apply chain rule, product rule, quotient rule, okay? And then keep in mind y is a function of x. So when we differentiate y with respect to x, we have to write dy over dx, okay? All right. Now, let's turn to page number 2. Okay. We're going to work on these two questions on page number 2. Okay, this question and this question. Okay. All right. This example. Who want to read the question for us? Any volunteer to read? Grant?
Use implicit differentiation to find an equation of the tangent line of the curve at a given point. 2 times x squared plus y squared equals 25 times x squared minus y squared 3, 1.
Yeah, I was a point 3, 1. Okay, very good. Okay, good. Use implicit differentiation, find equation of the tangent line to the curve at a given point. This type of question looks very familiar to us, right? Yeah, so we tried, we did many questions, in this type. Well, for this specific question, find the equation of the tangent line. Tangent line is a straight line, right? Remember, it's always like this. In order to write down an equation for a straight line, we need to know one point on it, right? So what is a given point? 3, 1. We know it, right? The other key for us is to know what? Slope of the line, right? So once we know the slope, we know the point, we can use point slope form to write it down, right? Y minus b equals f prime of a equals x minus a. Remember that? Okay. So, to find the slope of this straight line, we know it equals what? The derivative, okay, I would say y prime or f prime, or in this question y is implicitly a function of x, so I would say dy over dx. This is a derivative of y with respect to x at when x equals what? A. What is a value in this question? 3. Right? So, to find the slope, once we find the slope, we're almost done, right? But how to find the slope? We need to find what? Dy over dx, the derivative of y with respect to x, right? So now the question changed to be what? Find the dy over dx from this given equation. How? What to do? Differentiate both sides with respect to what? X. And then solve for dy over dx, okay? So same step, okay? Differentiate, okay, both sides of the equation, okay? Yeah. You can say differentiate this equation from both sides, okay, with respect to what? X, okay? Now let's see what we will have, okay? I would say, I will write this down like this. 2 times by x squared plus y squared square dx. Right side is b of what? 25 times x squared minus y squared dx. Alright. Differentiate 2 times x squared plus y squared with respect to x. We have a power, right? So at first we're going to use what? Power rule, right? So this whole thing square derivative should give us what? 2 times this thing, right? Times by this given 2. That's going to be 4 times by x squared plus y squared, right? By using the chain rule, we have to differentiate what? X squared plus y squared with respect to x. Guys, do you see that? By using chain rule, okay? Consider this is our g of x, okay? Yeah, what g, function g, okay? So 2 times g squared. By using the power rule, give us the 4 times g, and then g prime, right? Yeah. Simon, got it? Okay. Right side. We have a 25 times by x squared times by y squared. Here, guys, this is a multiplication between the constant by this function, right? So how to differentiate it with respect to x? 25 is what? A constant. Multiply 25, right? Remember, c times f of x, derivative is c times by the derivative of f, right? So 25 times by x squared, derivative with respect to x. What? 2x. What is negative y squared? We just did it. By chain rule, negative 2y times by what? dy dx. Everybody agree with this? Alright, now on this side we're not done. Okay, so 4 times x squared plus y squared times differentiate x squared plus y squared with respect to x. X squared, derivative, 2x. Y squared, 2y times by what? dy over dx. Right side, it is what? It is, if we distribute, okay, if we distribute, it is going to be 50x minus 50y times dy over dx. You guys agree with me? Okay, now we want to find what? dy over dx. Now for this question, everybody, for this question, We want to find the slope of the line. What is the slope of the line? The slope of the line is dy over dx when x equals 3 and what? Y equals 1, right? Why we need to use y equals 1? Because in this line, we not just need the x, we also need the y value. So, there are two ways to get m, okay? One way is what? Solve for dy over dx and then plug in the xy value. The other way is what? We're not solving dy over dx at first. We're going to plug in the xy value at first. Why? Because x squared, y squared looks so complicated, so abstract. But we know the value of x should be 3, y value is 1. So I'm going to plug in the xy values from this step and then solve for dy over dx. Okay, so how? Now plugging x by 3, y by 1 give us 4 times by 3 square plus 1 square times by parentheses 2 times 3 plus 2 times 1 times by dy over dx equals, what's the right side? 50 times by x, which is 3, minus 50 times by what? 1 times by what? Dy over dx. See now? Except for dy dx, everything else are what? Constants. But we have to be careful about the order of operations, okay? Alright. Parentheses, we have always do with the parentheses, right? What is 3 squared plus 1 squared? 10. 10 multiplied by 4, 40, right? So I would say 40. 2 times 3, 6. 2 times 1, 2. Times dy over dx. 50 times by 3, 150. Minus 50 times by what? Dy over dx. Everybody? To solve for dy over dx. So, just like solve for equations, right? 40 times by 6, 240. 40 times 2, 80. Equals 150 minus 50 times dy over dx. So that's good. Alright, so to solve for dy over dx, what do? We're going to add 50 dy over dx from both sides, right? So we will move this term to the other side, give us what? 80 plus 50 is what? 130 dy over dx, right? 150 minus 240 give us what? Negative 90. So dy over dx should equals negative 90 over what? 130, it is negative 9 out of what? 13. Whew. This is actually not just dy over dx. This is dy over dx when x equals 3, y equals 1. This is a slope. I would say this is not just dy over dx, because dy over dx is an expression of x and y. And then once we have the specific value, it is a slope, okay, m. Right? Okay, so we know the slope equals what? Negative 9 out of 13. We know the given point. So how to find the equation of the line? I use a point slope form at first. What is the point slope form tell us? Y minus what? 1 equals slope m, which is what? Negative 9 out of 13 times by x minus what? 3. We prefer to write this equation in terms of the slope-intercept form. Y equals mx plus b. So we have to simplify this. Okay, we have to simplify that. Okay, so this gives us y minus 1 equals what? Negative 9 out of 13x. Negative 9 out of 13 times by negative 3 give us what? 27 divided by 13, right? And then plug 1, adding 1 from both sides. So y equals negative 9 out of 13x plus 27 over 13 plus 1. What should we have? 40 out of what? 13, right? What do you feel? It's not bad, right? But we're reviewing the old knowledge about how to find an equation with tangent lines. Do the same thing, same idea. Figure out the slope, and then by using a given point, we write down the equation. However, how to find the slope? Well, for this question, we use the what? Implicit differentiation, right? All right. So this is question. Yeah, this is this problem. Can we move on to the next one? Find the y prime by implicit differentiation. We already found the second order derivative at first. We have to find what? First order derivative, right? So how to compute the y prime? Well, actually this y, we may isolate the y on one side. Yes, we are. However, the question says by using implicit differentiation. So let's use implicit differentiation, okay? So by using implicit differentiation, first we're going to do what? Differentiate this equation from both sides with respect to x. So left-hand side, differentiate with respect to x. X, the first power will give us what? 4x to the cube, right? Y to the first power with respect to x. By chain rule and power rule, we should have what? 4y to the cube times what? dy over dx, or y prime. Okay, either way. Okay. And then 16 is a constant. Derivative with respect to x give us what? 0. You guys, do you see that? Alright, so 4 for dy over dx, or y prime. How? Yeah, subtract by 4x cubed from both sides. Give us a 4y cubed times by dy over dx equals negative 4x to the cube. So, dy over dx equals negative what? 4x to the cube divided by what? 4y to the cube, right? And this dy over dx, we know it equals y prime, okay? And simplify first order derivative equals negative x to the cube divided by what? Y to the cube.
Isn't it a negative divided by a negative? Wouldn't that be positive?
Why this is negative divided by negative?
Oh, I'm sorry.
It is
Sorry.
negative divided by positive.
Sorry.
Yes, you're right. If it is negative divided by negative, we get a positive. But this is negative over positive.
And somehow in my brain I thought, okay, I'm moving them over, so.
We're not done yet. We need to find what? Y prime prime. Okay? So from y prime to find y prime prime, what do? Differentiate the negative x to the cube over y to the cube with respect to what? X. Right? So, now this is a quotient. We should use which rule? Quotient rule, right? So the differentiation is going to be negative, is still negative. X to the cube divided by y to the cube. By using the quotient rule, we're going to have a y to the cube, what? Square. Right? Then, we differentiate the top with respect to x, give us what? 3x squared times by the bottom, which is y to the cube, and minus what? Minus. Keep the numerator, and then differentiate y cube with respect to x. Differentiate y cubed with respect to x. It's always differentiated with respect to x. Okay? How? 3y squared times by what? dy over dx, or y prime. Okay? Either way, okay? Everybody seems good? Keep in mind, okay, we're differentiating with respect to x. Okay, y is a function of x. And then when we need to differentiate y with respect to x, we just write dy over dx or y prime. Okay, now you see everything else are good except for the y prime. What is y prime? Negative x to the cube divided by y cube. So what do? We're going to plug in y prime by this, right? So, okay, negative 3x squared y to the cube minus, this is 3x cubed y squared, right? I read the 3 in front, right? 3x cubed y squared times by y prime. What is y prime? Negative x to the cube divided by what? Y to the cube. You agree with me? And then what's y to the cube square? Y to the 6. Right? Okay, simplify. Okay, simplify. There's a y square, there's a y to the cube. Square cancel out. There is a y left. Okay, so let's rewrite it as negative is still in front. 3x squared y to the cube. This becomes what? Negative 3 times negative 1 give us positive 3, right? X to the cube, x to the cube times by x to the cube give us what? X to the 6 and divide by what? Y, right? See? Positive 3 x to the 6 divided by y, right? And then divide by what? Y to the 6. Oh, the video is still recording, right? So, but we're almost done, right? But see, there is a y here on the bottom. We don't like that. So how do we get rid of this y on the bottom? We multiply y from both top and bottom. Okay, and we distribute this y to each term. Okay, see what do we have? Negative 3x squared times y cubed times y. 3x squared times what? Y to the 4th power, right? Cube times y, 4th power. And then this y times this y, okay, this y and this y cancelled out, right? So we should have a 3 times what? X to the 6. And then on the bottom, we have what? Y to the 7th.